Okay, today is October 31st, 2022, and we are currently working on section 3.1 in your Math Links 9 textbook on exponents. So we've already did a video on exemplars and how to do different things. And with the first question, number 4, that we started at, says, write each expression as a power and evaluate. So because we have repeated multiplication of 7 times 7, 7 is your base. And the number of times you're multiplying it by itself is what we call the exponent. So when I say 7 squared, we can say this is called a power. So 7 squared is the exponential form, or when written as a power. And evaluate means what is its value? It would be 49. In B, we have 3 multiplied as the base, multiplied by itself 3 times. 3 times 3 is 9. 9 times 3 is 27. So evaluating it makes it 27. 8 is used in repeated multiplication, so it's its base. How many times is it multiplying by itself? It's 5. Now at this point, I have no idea what 8 times 8 times 8 times 8 times 8. I can't even do it in my head. So when I grab the calculator, I have two options. I can do 8 times 8 times 8 times 8 times 8 and press the equals button. And it will say 32,768. Or, alternatively, I can go 8, and then I can press this button right here, the XY button. And when I say 8 and then the XY button, that tells the computer, the calculator, that 8 is my base. If I then say 5, I then am saying that that's the Y value or the exponent, and then press equal, I get the same answer of 32,768. 32,768 as an evaluated standard form. And the last one, we have 10 multiplied by itself, 1, 2, 3, 4, 5, 6, 7. And the interesting thing is when you have 10 as a base, the easiest way to write it in standard form is simply put a 1, and then whatever your exponent is, that's how many zeros you add. So 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, comma, 1, 2, 3, comma. When I read that in standard form, it's 10 million. The next one, say evaluate each power. So 5 squared, written repeated multiplication would be 5 times 5, which is 25. 3 cubed, or 3 to the exponent of 3, is 3 times 3 times 3, or 9 times 3, which is 27. 4 to the exponent of 5 is 4 times 4 times 4 times 4 times 4, which in my brain is too difficult to do in my head. So I grab my calculator. 4 is the base, 5 is the exponent, equals 1024. We didn't have to do this one? We're doing it anyway. We had to do 5? We skipped it? Yeah. Okay. Well, we're just on 6 now. I skipped the wrong one. Doesn't matter. When we look at 7, what is the value of each power? So 8 cubed is 8 times 8 times 8. 64 times 8, I have a hard time, but I do know that it's 512, I think. Check with your calculator. 8 is the base, that's my x value. 3 is my exponent of y. Press the equals button. Still 512. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the exponent of 6 is 64. Double check with the calculator. 2xy 6 equals 64. And finally, 1 multiplied by itself any number of times will still have a standard form of 1. So regardless of what your exponent is, 1 to any exponent will always have a standard form of 1. Question number 8 says copy and complete each table. So 6 times 6 times 6 is 6 cubed. Grab your calculator. What is 6 cubed? The answer is 216 in standard form. What is 3 times 3 times 3 times 3? As a power or exponential form, it's 3 to the exponent of 4. Now the interesting thing is I could do this in my head. When I think of this, if I think of this as two separate multiplications, it doesn't matter the order in which I multiply. But 3 times 3 is 9, and 3 times 3 is 9. So instead of doing 3 times 3 times 3 times 3, I'm just going to do 9 times 9, which is 81. 49, there's actually two answers you can have for repeated multiplication. 7 times 7, or 7 squared, is the most obvious. But you could also write it as 49 to the exponent of 1. That's also as a standard value, the number 49. 11 squared in repeated multiplication is 11 times 11, or 121. And 125, again, you could go 125 to the exponent of 1, which is kind of a cheat. Or, if you knew that 5 times 5 times 5 is 125, you could say 5 cubed is also 125. Question 9. Does 4 cubed equal 3 to the exponent of 4? Show how you know. So when I say 4 cubed, I mean 4 times 4 times 4. And when I say 3 to the exponent of 4, I mean 3 times 3 times 3 times 3. When I show it like that, 4 times 4 times 4 is actually 64. And 3 times 3 times 3 times 3 is 81. And since 64 does not equal 81, I can definitively say that 4 cubed is not the same thing as 3 to the exponent of 4. Question 10 asks us to evaluate each power. Now the first question has brackets around the negative 9. And when you have brackets around the negative 9, the reason why there's brackets here is to define the base as negative 9, which means because that's the base, it's also used in repeated multiplication, which means in standard form it's evaluated as positive 81. However, the next one actually is not read as negative 5 cubed. It's read as the opposite of 5 cubed. The opposite of. So when this negative sign is not within brackets, it is not attached to the base, and therefore is not negative 5 times negative 5 times negative 5. What it actually says is the opposite of 5 cubed. And since 5 cubed, we just did it before, is 125, then the opposite of 125 is negative 125. Now you might have got that right, but did it completely wrong, because ironically enough, these two are actually the same thing, aren't they? Even though they don't mean the same thing, in standard form, both of them would have a value of negative 125. So you might have got the right answer, but got it the wrong way, right? And the last one, negative 2 to the exponent of 7, is negative 2 times 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 negative 2. And when I think about this, if I'm multiplying a negative by itself an even number of times, I'll always get a positive answer. If I'm multiplying a negative integer by itself an odd number of times, I'll always have a negative product. So really, I know my answer is going to be negative because I know that an odd number of negatives multiplied together will be negative. So 2, 4, 8, 16, 32, 64, 128. It should be negative 128. Is that right? We'll double check our answer. When I go to my calculator, this time I'm going to let the calculator know that negative 2 is my base, so I'm going to press the XY button. And then I'm going to press the exponent of 7, or the Y value, and hit the equals. And it's negative 128. Change my color to green. Does this say negative 8 squared, number 11a, or does it say the opposite of 8 squared? It says the opposite of 8 squared, correct? So when we skipped 11? Well, we'll do it anyway. So if it says the opposite of 8 squared, since 8 squared, if I want to write it in repeated multiplication, here's what it looks like. The opposite of 8 squared, the opposite of 64, the opposite of 64 is negative 64. You can also think of that as being a negative 1, because technically when you multiply something by negative 1, you get its opposite. So if I gave you the number negative 6, if you multiplied negative 6 by negative 1, you'd get positive 6, which is its opposite. Does B say the opposite of 1 to the exponent of 5 or negative 1 to the exponent of 5? Because it's in brackets, that's what it says. So therefore, it's negative 1 times negative 1 times negative 1 times negative 1 times negative 1. An odd number of negatives is going to be a negative product. And 1 multiplied by itself any number of times is still going to be 1. So in standard form, it's going to be negative 1. Now C is a great example of how do I read mathematics. Can anyone tell me how you read C? Not negative. You don't say negative. How do we say it back here? The opposite of. So C is actually read as the opposite of negative 3 to the exponent of 7. Right? Do you see it? The opposite of negative 3 to the exponent of 7. So if we could figure out what this is, since negative 3 is in brackets, it's used in multiplication. So I'm going to actually take my calculator and say negative 3 xy to the exponent of 7 equals negative 2,187. Negative 2,187. Negative 2,187. What is the opposite of negative 2,187? Positive 2,187. Or alternatively, if you want to think of it as multiplying by negative 1, what's negative 2,187 multiplied by negative 1? It's positive 2,187. Question 12 gives us this table, gives us repeated multiplication, gives us exponential form, asks us to evaluate. Actually, A I can do without grabbing a calculator. What's 3 times 3? What's 9 times 3? So it's going to be a positive 27 or a negative. Because it's an odd number of negatives we're multiplying together, it'll be a negative product. The next one is negative 4 multiplied by negative 4, or negative 4 in brackets squared, which is a positive 16. Next one is in brackets, negative 1 multiplied by itself 3 times. So I write it in exponential form. I'm going to keep my brackets around the negative 1. And negative 1 times negative 1 times negative 1 is still negative 1. That's too funny. Forget I just laughed. There's a costume just walked by. It was quite funny. Negative 7 in brackets squared will be negative 7 times negative 7, which is a positive 49. Now the next one's interesting because there's multiple ways you can do it. Negative 10 in brackets cubed would be negative 10 times negative 10 times negative 10, which would give you negative 1,000. But technically, you can also write the opposite of 10 cubed, which would be the opposite of 10 times 10 times 10, which would still be negative 1,000. So actually, both of them are going to give you the same standard form of negative 1,000. I'm assuming most people wrote this one, but if you wrote this one, you would still be technically right because the opposite of 10 cubed is still negative 1,000. Here's a question for you. What would this be then? The opposite of negative 10 cubed. Since negative 10 cubed, we already said was negative, this would be the opposite of negative 1,000, which would actually end up being a positive 1,000 if you think of it that way, right? The opposite of negative 1 cubed. Okay. Question 16. Arrange the following powers from least to greatest value. Let's evaluate. What's 1 to the exponent of anything going to be? 1. 3 to the exponent of 4 is 81. 4 to the exponent of 3 is 64. 2 to the exponent of 5, 2, 4, 8, 16, 32. And 7 squared is 49. So from smallest value, our smallest value is 1 to the exponent of 22. Our next smallest value is 2 to the exponent of 5. Our next smallest value is 7 squared. Our next smallest value is 4 cubed. And our finally, our largest value is 3 to the exponent of 4. And that's rearranged from smallest to greatest value. Question. Oh, I think that's all we have left here. I guess what's question 17 says a single bacterium doubles every hour. How many bacteria are present after 15 hours? Okay, so for question 17, when we have our formula, it says a single bacterium doubles every hour. How many bacteria are present after 15 hours? So A is going to represent our starting number. And how many bacteria do we start with? So when we substitute that, we're going to put the number 1 down here. And R is the number of, the rate of change. So in this particular case, it doubles, which means our R, our rate of change, since it's doubling, is going to be the number 2 for doubling. And the X here is the number of intervals, which means if it doubles every hour, and the question is how many bacteria are present after 15 hours, how many time units are we talking about? We're talking about 15 intervals. So when we use this formula, A multiplied by 1 plus r to the exponent of x. It looks very complicated, but when we substitute our information, this 1 simply represents how many bacteria or how many objects we started with. This 2 simply represents the rate of change, in this case doubling. And this x up here, this 15, is simply how many time intervals is there. So when we simplify that, 1 multiplied by 3 to the exponent of 15, do I do my multiplication first or my exponents first, according to BEDMAS? Exponents. So when I go 3xy to the exponent of 15, that is 14,348,000. Wrong button. 907 multiplied by 1, which means at the end of 15 hours, there will be 14,348,907 bacterium present. And the last question, I think. Express 9 as a power where the exponent is 2 and the base is positive. So if my exponent's going to be 2 and my base is positive, then 3 squared is going to be a positive 9 as a power. So 3 squared will give you a positive 9. If my base is negative, I need to put brackets around it. And therefore, I would still have a positive 9 in standard form.